We have three different kind of matters, that is solid, liquid, gaseous. These are the things we learned in our early classes, our childhood also. So here we discuss about fluids, how fluids react, what are the characteristics of the fluid, so how it will utilized in an equipment in a right way. So what are the different kind of aspect happen in a fluid, what it can do in favor of engineering. So these are the things will be discussed by acquiring the knowledge of the characteristics and properties of the fluids. So this is our first unit. So first unit is fluid properties and fluid characteristics. So our topic is fluid mechanics and machinery. So first of all we have to see fluid. So it have a flow property. So there is no definite shape, but where we can store the fluid, it can occupy the shape where it's stored. That is the main thing. Then fluid, this is the fluid. The mechanics means how it will react, how it will move. So what are the different aspect of the fluid when we apply certain forces? So what will be the reaction when we are applying forces, and what will be the reaction in without forces? So these are the things to be considered in fluid mechanics. That is the mechanics here. So fluid mechanics is a branch of science. Actually engineering is based on science, which deals with the behavior of fluid at rest and in motion. We can analyze the fluid in both rest as well as in motion. So how it will react both rest as well as in motion. So certain fluids we consider in rest condition. So what will be the things happen in rest position? If a fluid in motion, so we can call it as the body in motion, the fluid in motion. So what will be the different kind of aspects happening in a fluid? So these are the things we learned in physics, simply we can say in science. So that is Newton laws. So Newton law is applicable for both fluid, liquid. So what it specifically means, in first law every body continues in its states until external forces acting upon it. So that means if an object in a regular motion, when it will stop means when we apply the resistive force, then only it changes its positions. If object in motion means it will stop. If object in rest position means it's ready to move. So these are the things happening in Newton laws base. So the same thing happening in a fluid at rest as well as in motion. So these are the fundamentals we are utilized in fluid mechanics. So fluid mechanics is classified as fluid statics and fluid dynamics. So fluid statics means the object in rest position. So that is statics, that is stationary one. So that is the major thing here. Then fluid dynamics. So fluid dynamics means the object in motion. So in motion we can categorize into two categories, fluid kinematics and kinetics. So the term kinematics, it specifies the fluid in motion without consideration of force. We need not to bother about the force, what is the force acting on the fluid. These things we won't be considered. That is fluid kinematics. If kinetics means we need to consider certain force. So what will be the force acting on the fluid? So depend upon the force, how it will react. These are the things will be discussed in fluid kinetics. So these are the main things here. Then next we move on to properties of fluids. In properties of fluids, The first one is mass density, or simply we call it as density. So it's denoted by rho. So that is we can define it's a ratio of mass to the volume of the fluid. This mass. So we can simply say, so density, we denote density by rho. So density rho is equal to mass per volume. So mass, the unit for mass is kilogram, the unit for volume is meter cube. So unit for density or mass density is kg per meter cube. So simply we can say density of water. So density of water is 1000 kg per meter cube. This is the density of water. Then specific weight and weight density of fluid. We can move on with density or mass density. So when we know very well. So mass is converted into weight when consideration of gravitational force, that is G. So these are the things applied here. So if we consider density with acceleration due to gravity, we call it as weight density. So these are the things we mentioned here. You can specify with W. Okay. So here specific weight or density, weight density is defined as, it's a ratio of weight per volume of the fluid. So these are the definition here. So and we can simply specify weight density or specific weight W. We need to denote with W is equal to weight of fluid by volume of fluid. So that is equal to rho into G. So rho into G means that is rho is 1000, then G is 9.8. So the mass is converted into weight and multiplication of the gravity. So here the weight of the fluid or specific weight or weight density of fluid is equal to Newton per meter cube. So Newton specifies the weight and meter cube specifies the volume. So these are the things here. So here the value of weight density of water is equal to 9.81 into, so density of water 1000. So 9.81 into 1000. So 9810 Newton per meter cube. This is the weight density of the fluid. Then specific volume. Then specific volume is the reciprocal of density. Okay. So specific volume means reciprocal of density, or we can simply say whenever we use the term specific means the denominator should be in mass divided by mass or divided by kg. So that is called specific. A specific volume. So volume divided by mass. So these are the terms we have to utilize in specific. So what will be the volume based on the mass? So here the unit is so volume is meter cube, then mass is kg. So meter cube per kg. This is the value of specific volume. Then specific gravity. We can say specific gravity or relative density, that is equal to specified by S. S is equal to is defined as the ratio of density of fluid divided by density of standard substance. So we have fluid as well as gas has mostly similar characteristics. So we have to use Fluid means we have to consider water as the standard substance. When we are using gaseous components or gaseous state fluids, we can use air as the standard substance. So these are the things here. So we can utilize both the terms. So density of fluid by density of water we can use, or we can use weight density of fluid divided by weight density of water. So whatever may be, we can use, but we can get the same value. But there is no unit for specific gravity or relative density. Why means it have both the values get changed. Both the numerator as well as denominator get cancelled. So these are the things here. Then properties of fluid means viscosity. Viscosity is defined as a property of a fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of the fluid. So we can feel the difference. So when we drop the water on the floor, means it will move very fastly because it has very low viscosity. So it can move very fastly. Why it move very fastly means the bonding between the molecules is very less. The cohesion is very low. So when comparing with oil, when we drop the oil in the floor space, it will move very slowly because of it's have very bonding with the molecules. So it never move very easily. So these are the things. So this is the term viscosity, the resistance to flow. If I have a strong bonding, the flow never get in a fast manner. It move in a very slow manner. Then Newton law of viscosity. So it states that the shear stress on a fluid element layer is directly proportional to the shear strain, rate of shear strain. So we can use mu is equal to tau into du by dy. We can use the term poise as a unit for viscosity. Then we can use kinematic viscosity. Kinematic viscosity is it's a ratio of dynamic viscosity per density. So we can use Stoke as the unit for here. So these are the things here.